Let us understand how we can manage constraints. We can add constraints while creating the tables or after creating the tables. Constraints such as not null, check, foreign key are automatically dropped when we drop the table. Even primary key and unique constraints are dropped if they are not used to enforce constraints. When primary key or unique constraint is referred by child table, then there can be errors. We can add constraints to existing table using alter table with add. We can specify the name using constraint keyword. If you don't want to provide the name, you can ignore that. Then it will start using the system generated names. However, if you want to specify the name, you have to use constraint keyword. Then you have to specify the name of the constraint. Then you have to say primary key or foreign key or unique, etc. Constraints from the table can be dropped using alter table with drop. Let us perform tasks to understand how we can use alter command to add or drop the constraints. Use the prior users table without any constraints. So first we will create a table without any constraints. Then we will add primary key constraint on user ID, unique constraint on user email ID, not null constraints on user email validated, user role, created date, last updated TS, etc. Add check constraint to user role with U and A as accepted values. Add new table user logins with below columns and establish foreign key relationship with users. This user login details will have a column called as user login ID, which is of type serial and primary key. User ID will be of type int. User login time will be of type timestamp defaulted to current timestamp. User logins is child table to users with a many to one relationship, which means for a given user there can be many user logins. That's why we have many to one relationship between user logins to users. If we talk from users to user logins, we have one-to-many relationship. Hence, we will be creating a foreign key between user logins user ID to users user ID. Let's load the SQL magic. It was already loaded earlier, that's why it is throwing this error. We can ignore it. Let's define this environment variable called as database URL, which have all the information related to connecting to a database. Now, this command will take care of dropping the users table if it already exists. This will take care of dropping the sequence. Now if you look at this users table, it have only user ID, first name, last name, email ID, email, validated, password, role, is active, created date, etc. And there are no constraints except for not null. If you want to specify constraints while creating the table, you can specify like this. Even with respect to columns like user role, where you want to enforce check constraint with only U and A as valid values, you can define constraint like this. You can say check, and then you can actually say U comma A, so that anytime a record is inserted into the table, it will be checked against user roles for U or A. Now let me create the sequence. I am assigning the sequence to the user ID, and then I am setting some default values. These are just to make sure that the users table is created with the original requirements as we have seen as part of the previous topics. Let's run these commands. These are not related to adding any constraints. Now let's validate this table called as table underscore constraints, which will give us the details with respect to the constraint name, constraint type, etc. You can see that there are only check constraints against not null. Other than that, there are no other constraints. So on users, we have 3 constraints. All of them are not null constraints, and these are the ones which are shown up there. Now we want to perform tasks such as creating primary key on user ID. This is how you can take care. You can say alter table users, add primary key, and you can specify the column on which you want to enforce the primary key. Now you can run this, and then you should be able to run this, and you can see that the primary key is created using name users underscore p key, which is a system generated name. We haven't specified the name, it is just added with the system generated name. We can drop the constraint like this, and you can review this table. There is no primary key constraint. However, even after dropping it, the not null is still there on top of the column user ID. It did not clean up the not null constraint. It could be bug, or it can be the feature of Postgres. We don't know whether it is a bug or feature, but keep in mind that when you drop the primary key constraint, the not null is still enforced, even though the uniqueness will not be enforced further. Now, if you want to add the primary key constraint with the name, this is how the syntax will look like. Earlier, we have created the primary key constraint without user specific name. Using this, we just said alter table, table name, add primary key, and we have specified the column on which primary key has to be enforced. And you can see that a primary key is created with this name, users underscore p key, which is nothing but system generated name. If you want to explicitly specify the name, this is how it will look like. You just have to say alter table users, add, which is same as earlier, and also this part is same, primary key, the column name. However, you just have to have this constraint and constraint name after add. This will take care of adding the constraint with user specific name. Now you should be able to validate, and you can see that the constraint name is users underscore pk, not pk key, pkey. It was created with pkey earlier, now it is just pk. Now let's add unique constraint against user email ID. Once again, if you want to give a user specific name, you just have to say add constraint name and then unique, and then you can specify the user email ID. In this case, I just want to create it with system generated name, and hence I haven't specified the constraint name here. That's why there is no add constraint and constraint name. Directly we have add unique and the column name on which the unique constraint has to be enforced. Now let's run this to see how the unique constraint is added to the table. The system generated name is nothing but table name underscore the unique column, which is nothing but user email ID underscore key. This is how the unique constraints will be added with system generated names. Now I want to enforce not null constraint for user email validated, user role, created date, last updated timestamp. This is how you can take care, and this is how you can take care of enforcing a check constraint on user role to only accept URA as valid values. Any different value than URA when you try to insert into users, especially the user role column, will be rejected. You will get an exception saying that check constraint violated. Now let's run this query, which will actually give us the details about all the constraints that are created so far on our users table. You can see we have these many constraints. Most of them are not null constraints, and then we have a check constraint, a primary key constraint, and unique constraint. Now let's create a table called as user logins. It have 4 columns: user login ID, which is of type serial, which is nothing but integer with sequence generated numbers. User ID is of type integer. If you want to define a foreign key relationship between this user ID to user's user ID, you can define foreign key like this. You just have to say foreign key users of user ID. However, this is not a good practice. We typically don't define foreign keys while creating the tables. We typically define them after the fact of creating both the tables between which we want to define the relationship. On top of user login ID and user ID, we have additional columns such as user login timestamp and user IP address. And let's create this table. Let's review the constraints against user logins table. We have only primary key and a not null constraint. Now we can say alter table user logins, add foreign key user ID, references users user ID. However, if you want to create this constraint with user specific name, you can actually say constraint and give the constraint name here, and then you can follow with foreign key references, so on and so forth. In this case, I will leave it to system generated names because system generated names are typically verbose when it comes to Postgres, and hence I am just adding the foreign key with the system generated name. And now I should be able to run this query to actually see the foreign key constraint, and the constraint name is nothing but the child table name, which is nothing but user logins underscore the column on which the foreign key is defined underscore f key. F key stands for foreign key. Now if you want to drop the table, this is how you can drop the table. However, this drop table command will fail because we have a child table user logins for users table. You can see the error here. Constraint user logins user ID f key on table user logins depends on table users. Use drop cascade to drop the dependent objects too, and this is a hint. If you like this hint, you can actually execute based on this hint, and we should be good to go. Otherwise, we might have to drop the constraint explicitly, and then we have to drop the table. So either you can drop the foreign key constraint and drop the table, or you can just follow this hint by actually specifying cascade at the end, and this will take care of dropping the parent table by only dropping the constraint on the child tables. It will not touch anything else with respect to the child table except for the dropping of the foreign key constraint, which is defined pointing to this table. You can actually validate by running this query. We have the primary key constraint on user logins, but the foreign key constraint is dropped, after which only the table users is dropped. Now if you just want to drop user logins, you can drop this. It will take care of dropping all the primary key constraint and check constraints. Even if you have indexes, even those will be dropped. This is how you should be able to manage the constraints on the tables or between the tables. We can manage any type of constraints. Most commonly, we will be dealing with the not null constraint, check constraint, unique constraint, primary key constraint, and foreign key constraints.